Alright, I'm going to keep going through these examples for those of you that want more assistance. So the distribution of heights of young women aged 18 to 24 is approximately normal with a mu of 64.5 and a standard deviation sigma of 2.5 inches. Alright, sketch the normal curve that approximates the distribution of young women's heights. Label the mean and the points that are 1, 2, and 3 standard deviations from the mean in both directions. Alright, my normal curves are awful. I just do the best I can. Alright, I know the mean is right in the middle. And here I've got 1, 2, and 3 standard deviations above and 1, 2, 3 standard deviations below. Alright, let's go ahead and make sure I've got all my points. So we know that the mean is right in the middle, so my mean is 64.5. Alright, so my standard deviations above the mean. 64.5 plus 1 standard deviation of 2.5. For once, I would just like to write what I mean. Alright, after that, I'm going to add 2 standard deviations, and then my last one I'll be adding 3 standard deviations. Alright, so 1 standard deviation above the mean is going to give me 64.5 plus 2.5. So that's going to give me 67. That's 1 standard deviation above the mean. Alright, 2 standard deviations above the mean, I'm just going to add it twice. That's going to give me 69.5. So you see how you could have done 2 times 2.5 and that would have given me the same answer. So see, 64.5 plus 2 times 2.5 still gives me 69.5. So that's plus 2 standard deviations. And then my last one, I'm going to add 1 more standard deviation from the mean, and I get 72. Alright, so that means I'm going to label my normal curve. I have 69.5 here, 67 here, 69.5, and 72. So those are all my standard deviations above the mean. Now let's figure out what my standard deviations below the mean would be. Now I'm going to subtract. So I'm going to subtract 1 standard deviation, then I'm going to subtract 2 standard deviations, and then I'll subtract 3 standard deviations to get my 3 points that are below. Alright. 64.5 minus 2.5. It's going to give me 62. Alright, I'm going to subtract another 2.5 to get my next one. It's going to give me 59.5. And then I'm going to subtract another standard deviation to get my last one. Get out of here. Alright, 57. Alright, so 1 standard deviation below is 62. 2 standard deviations below is 59.5. And 3 standard deviations below is 57. So I've got my normal curve, got my mean in the middle, my 3 standard deviations above the mean, and my 3 standard deviations below the mean. So I'm always going to write my little abbreviation. N means normal. The first number, I'm going to write it like an ordered pair. The first number is going to be my mean, and my second number is going to be my standard deviation. That's just so I know what's shown in this graph. Normal, my mean, and my standard deviation. And that's my standard deviation drawing, or my normal curve drawing. Alright. If I told you that a data value had a z-score of 1, what would that value be? Remember, a z-score is z-score is number of standard deviations above or below the mean. So if I was 1 standard deviation above the mean, I would be 67. What if I had a z-score of 2? I would be 69.5. What if I had a z-score of -3? I would be 57. All right, now this asks us, what percent of young women have heights less than 69.5 inches? Show your work. All right, so if I'm talking about heights that are less than 69.5 inches, let me highlight in my, all right, I'm going to have to, let's see, 69.5. All right. So this is asking for the percent of heights that are less than 69.5. So everything less than 69.5. Well, I know between 62 and 67 is 68% of the data because of my rule, right? I know 2 standard deviations away from the mean is 95% of the data. And I know 3 standard deviations is 99.7, but this isn't 3 standard deviations, right? This is the only side that's shaded. That's not shaded. So I need to pull out my little guide that we did earlier in class today. So remember, we split up the 68% into 2 34s. We split up the 95 into 2 47.5s, and we split up the 99.7 into 49.85, 2 halves, right? So looking at this, it looks like I've got the entire left-hand side, and the entire left-hand side of the mean is going to be 50%, right? Everything to the left of the mean is 50%. Plus, I need to figure out what's my percentage to the right of the mean. So what percentage did we say was 2 standard deviations above the mean? 47.5%. So I'm going to add 47.5%. So that's going to give us 50 plus 47.5 gives us 97.5%. So that's about what percentage of women have have heights less than 69.5 inches. So most women, right? That's you are at the 97th percentile if you're 69.5 inches. All right. Okay. Is a young woman with a height of 62 inches unusually short? Justify your answer. All right. So 62 inches is below the mean, right? So I know that 50% is going to be below the mean, and I need to, if I'm only looking for 2 standard deviations below the mean, I need to subtract out the 34%, right? That'll leave me with 50% minus 34 will leave me with everything from here to the left, right? So 50 minus 34 is going to give me 16%. So only 16% of women are 62 inches and shorter. Do you think that's unusually short? Yes. She is unusually short because she is at the 16th percentile. 16% of young women are shorter than her. And 16% is a pretty small number, so there are not that many women that are shorter than her. So I would say, yes, she's unusually short. So remember, we took the second half of 50%, right, and we subtracted out what piece we don't have. So if I were to draw a little picture right here, we'd actually be looking for this shaded piece right here. So we said that's 50%. The whole thing is 50 minus the 34%. That's right here. So 50 minus 34 is going to give me 16%. want you to go ahead and attempt this AP practice problem on your own. So this is all one big problem. So go ahead, pause the video, read through it, and tell me what you think. A, B, C, D, or E. All right, so the words per minute spoken by a student at Talk University is approximately normal. So it's normal, with a mean of 150 words per minute and a standard deviation of 25. So remember, I put my mean right here and my standard deviation here. The shaded area in the figure below represents which of the following probabilities? All right, so the shaded area is between -2 standard deviations and 3 standard deviations. So let's go ahead and label what these numbers would be. So my mu is 150. So I'm going to take 150 and I'm going to subtract the standard deviation twice from it to get the starting value. So 150 minus 25 minus 25. See, I subtracted it twice. So this is 100. Now I'm going to add it 3 times to get to the third standard deviation. Plus 25, plus 25, plus 25. So 3 standard deviations above is 225. So looking at this, let's see which of the answer choices could this be. The probability the number of words per minute was between 75 and 200. That's not right. Between 100 and 200. That's not right. Between 100 and 225. That looks right. Between 125 and 200. Nope. And between 125 and 225. Nope. So all we need to do is calculate all of the z-scores down here, or I'm sorry, all of the values down here below by subtracting or adding the standard deviation to the mean. So I just took the mean, mu, and put it here at 0. I added 25 3 times to get here, and I subtracted it twice to get here. So from 100 to 225.